For 2015, the fine folks at Huddleston Performance have stepped up to the plate once again with our weekly tech tip. And this week, we've caught up with Jon Salemi. And John, what are we going to talk about today?
We are going to see a fuel system flow bench live and in action today.
Very, very cool. Let's go check things out.
We'll demonstrate a blown alcohol fuel system on the test bench here. And everything is controlled through this frequency controller for the 10 horsepower electric motor that's over here that we have connected to our mechanical fuel pump as it would be on the car, with fuel delivery up and through the barrel valve and into the nozzle section where we dictate nozzle area to control pressure, and all of our return lines. And basically what we're simulating here is RPM, engine RPM, and setting a linear fuel curve per engine RPM. So every 1,000 engine RPM we want a stable fuel flow rate to increase. So when we make a change to the fuel system, it affects it all the way from your lowest RPM to the highest RPM in the same manner. That way we keep the fuel curve linear as it goes up in RPM, so when we make a change to the main jet or the pump loop or any of the other jetting, it stays equivalent and it doesn't dip below and create a lean situation or go over the linear line and create a rich situation as the engine increases and RPM acceleration. So we'll demonstrate this here. We'll run it through a RPM sweep, and you'll be able to see the fuel flow coming in and dumping into what would be the manifold on a car, which we have a clear plexiglass plenum, I'll call it here, to show the massive amount of volume that these things actually consume. When I test, I'll test at each RPM. We will start at 2,000 RPM, and we'll swing the count all the way up. And as we're going up, we're getting pressure and fuel flow readings, and then I'll determine whether the curve is linear. And if it is not, I'll come back and make adjustments to the spring-loaded poppets to make a linear flat curve as it rolls up. I'll just roll up quickly and just give a quick demonstration of that. This would be how I would normally test, and I'd be marking each segment of RPM down. And this is all based off of a race pack deal, so it's very similar to what we see in the race car as well. And we always use 8,000 engine RPM as a baseline. And right now, this system is set up at 4,000 cam speed, which would be 8,000 engine RPM. At 16.7 gallons. So this one needs a little bit of adjustment, and we'll come back, make some adjustments, and we'll go from there. We can also close the injector hat and set this up for idle flow, which should only be working on the top hat nozzles. If you can zoom in here, this is the amount of fuel that we're considering at idle flow. So basically we have idle and wide open circuits. Our in-between circuit has been taken away with leaving off of a two-step, and that is dictated from how much return fuel you're returning when you're on the two-step. And this system here, we're about 17 or 1800 RPM here, and we're running like 0.6 or 0.7 gallons through it. And that's what it takes to idle one of these things with a torque converter set up so it idles down very low and it's easy to get in and out of gear. And at this point in time, the nozzles that go into the ports are off, and we're just using these top, or what we call the hat nozzles. And then as we open up, you can see, as I open the blades up and it opens the barrel up, you'll be able to see these port nozzles inject the fluid into the manifold. And that's all done off of spring-loaded poppets on our mechanical fuel system.
Man, that was really, really cool. Thanks so much, man. That was awesome.
Thanks for coming to have a look, and glad we could be able to show and create some insight for the fans and fellow racers out there.
Keep your eyes out once again for the Huddleston Performance Tech Tip of the Race.